Welcome back, everyone, for another deep dive. This time we're going to take a closer look at something you experience every day but might not give a second thought to: heat transfer.
It's true. You might not realize it, but it's the reason why you pick out that light t-shirt on a super hot summer day.
Or why you want that cozy sweater in the winter.
Exactly. We'll be exploring the science behind how heat travels and how that impacts, what you choose to wear.
So let's imagine just stepping outside your house on a scorching summer day. You instantly feel that wave of heat. But how do we actually know something's hot or cold?
That's a really good question. You see, our sense of touch, not always the best judge of temperature.
Like jumping into a pool on a hot day and the water feels freezing, even though it isn't actually that cold?
Exactly. That's why to get a really good reading, we need something a bit more scientific. Enter the thermometer.
Ah, yes, the thermometer. So how does a thermometer actually work?
Well, a thermometer is just a device that measures how hot or cold something is. And it works on this principle that, substances expand when heated and they contract when cooled. A common type that a lot of people have seen is the liquid in glass thermometer.
Right,
Uses mercury or alcohol.
right. Those are the ones with the silver liquid that goes up and down.
Yeah, so as the temperature goes up, that liquid inside the thermometer, it'll expand and move up that calibrated scale.
Gotcha. So the scale on a thermometer, is it usually divided into degrees Celsius?
Yes, degrees Celsius, that little degree C symbol you see.
Okay, so when we say 25 degrees C, we're using that Celsius scale.
Exactly.
All right, Celsius, that's how we measure it. But what would you say is a normal body temperature for us humans?
So normal body temperature for a healthy person is generally considered to be 37 degrees C, but keep in mind, it's just an average. There can be slight variations throughout the day.
So 37 degrees C, that's our baseline. Anything higher or lower could mean maybe a fever or something's up, right?
Yes. That's why doctors use a specific type of thermometer called a clinical thermometer. It measures body temperature. They have a range usually, typically from 35 degrees C to 42 degrees C.
So it covers that normal range plus a bit extra just in case.
Right.
Okay, so now that we've got the basics of measuring temperature down, let's talk about how heat actually moves. We know it goes from hotter objects to colder objects, but how does that happen?
Well, there are actually three main ways heat can be transferred: conduction, convection, and radiation.
Okay, three whole ways. Let's break them down one by one. What's conduction?
Okay, so conduction, think of it as heat transfer through direct contact, like a domino effect. When one molecule gets heated, it bumps into its neighbor and transfers that energy.
So if I touch a hot pan, ouch, the heat is being conducted from the pan to my hand.
Exactly. The molecules in that pan are vibrating super fast because the heat, and when you touch it, those vibrations, they get transferred to your skin. That's you feeling the heat.
Okay, got it. Conduction is direct contact. What about convection?
All right, convection is all about heat transfer, but through the movement of fluids. We're talking liquids and gases. It's about the circulation of warmer and cooler regions within that fluid.
So it's not just touching something hot, but the movement of the hot thing itself.
You got it. Imagine boiling water. So the water at the bottom of the pot, that gets heated first, right?
Makes sense.
As it heats up, it becomes less dense, lighter, and it rises. And the cooler water at the top, it sinks to the bottom.
So it's like a cycle.
Yes, a continuous cycle, distributing heat throughout.
Cool. Now, radiation, that one always sounds a bit mysterious. How does that work?
Radiation is heat transfer, but it uses electromagnetic waves. The big thing here is it doesn't need anything to travel through, unlike conduction and convection.
So it can travel through empty space.
Exactly. Think about the sun, that warmth we feel. That's the sun's energy traveling through space as electromagnetic waves, and then it warms the earth.
Wow, okay, so conduction is direct contact, convection is movement of fluids, and radiation, that's through waves,
Yeah.
even in a vacuum. Got it.
Perfect. Now that we've got these three ways down, let's pause for a sec. Do you have any questions about these three methods?
Well, I'm a little curious about the electromagnetic waves part. You mentioned heat from the sun traveling as radiation. Does that mean all electromagnetic waves carry heat?
That's a good question. Not all electromagnetic waves carry heat. There are actually a ton of different types, like radio waves, microwaves, infrared, visible light, ultraviolet, even X-rays and gamma rays. Each one has a different wavelength and a different energy level. It's mainly infrared radiation that we perceive as heat.
So our bodies, they can actually emit Infrared radiation too. That's how those thermal cameras work, right?
Absolutely. Every object gives off some level of infrared radiation. The hotter the object, the more it emits. Thermal cameras, they pick up this radiation and turn it into images that show, those temperature variations.
I remember seeing those thermal images of houses where the areas with heat loss show up as brighter colors.
Yep, that's exactly it. Those images can actually help pinpoint where insulation needs to be improved to save energy.
Fascinating. Okay, so we've got conduction, convection, radiation, the three ways heat can travel. Now let's connect this to something we deal with every day, clothing choices. Why do we wear what we wear in different weather? Let's get into that.
It's amazing how this basic heat transfer stuff affects what we wear every day. Think about getting dressed on a hot summer day.
Yeah, we automatically reach for those light colors, white or pastels.
Yeah.
But why? Is it just fashion or there's some science behind it?
It's all about radiation. Remember we talked about how dark colors absorb more of that radiant heat? Well, light colors, they're reflecting more of the sun's rays, keeping us cooler.
So wearing white is like having a little shield against the heat.
Exactly. And then in the winter, the opposite happens. Darker colors, they'll feel warmer because they're absorbing more.
Gotcha. So ditch the black shirt in summer. What about winter? Why do we want those big, thick sweaters?
Think about those wool sweaters. Wool is a fantastic insulator. That means it's not good at conducting heat.
So it keeps the heat in.
It traps air between its fibers, creates a barrier that slows down that heat transfer from our bodies to the cold air.
Like wearing a personal heater.
Exactly. That's why a wool sweater feels so much warmer than, say, a cotton one, even if they're the same thickness. That trapped air is like extra insulation.
This is making a lot of sense.
Yeah.
I do have a question, though, about convection. We talked about boiling water, but what are some other examples of convection in action?
Good question. Well, have you ever felt those sea breezes at the beach?
Oh, yeah. So refreshing. What's convection got to do with that?
It's all about how land and water heat up at different rates. During the day, the land heats up faster than the sea.
Makes sense, the sun beating down on it.
Right, so the air above the land gets warmer and rises. Then the cooler air over the sea rushes in to fill that space. That's your sea breeze.
So it's like the land is a big heater and the sea's a natural AC unit.
Pretty much. And at night, the reverse happens. The land cools down faster than the sea, so the cooler air flows from the land to the sea. Land breeze.
A constant cycle of air, all thanks to convection. So convection is like nature's way of balancing out those temperatures, moving heat from warm to cold areas.
Spot on. It's a key process that affects everything from local weather to, global climate patterns. Any other questions about convection before we move on?
Well, I'm thinking about that hot air rising. Does that mean hot air is always lighter than cold air?
That's a sharp observation. Generally, yes, hot air is less dense than cold air. When air heats up, the molecules move faster and spread out.
Makes it lighter.
Exactly. It becomes less dense. That's why it rises above that colder, denser air.
It's like those hot air balloons. They rise because the air inside is lighter than the air outside.
Perfect example. That balloon is pure convection in action.
All right, that makes sense. Let's switch gears back to radiation. We talked about the sun, but are there, everyday examples of radiation?
Of course. Think about standing near a fireplace. You feel that warmth, right? But you're not touching the flames.
Yeah, it's cozy.
That's radiation doing its thing. That heat travels to you in waves, mainly infrared.
So it's not the air around the fireplace warming me up, it's the radiation itself?
Exactly. It's that direct heat energy you're feeling. And it works both ways. Our bodies radiate heat, too. That's part of why we feel cooler with those light-colored clothes in summer. They reflect more of our own radiant heat away.
So we're like walking radiators.
You could say that.
Yeah.
And what we wear changes how much heat we absorb or reflect. Any questions on radiation before we move on?
This makes me think, if darker colors absorb more radiation, are some materials, better absorbers than others?
Good point. Yes, different materials can be better or worse at absorbing, reflecting, and emitting radiation. For example, let's say you leave a black t-shirt and a black metal pan out in the sun. They'll both absorb a lot of radiation.
Makes sense.
But the pan will feel much hotter to touch. That's because metal is a better conductor of heat than fabric. So even though they absorb a similar amount, that metal transfers the heat more efficiently to your hand.
So it's like a double whammy. The absorption plus how well it conducts the heat.
Exactly. Those heat transfer mechanisms often work together.
Okay, so we've got conduction, convection, and radiation down pat. But now I'm curious, how does all this apply to, making our homes more energy efficient, like building design and stuff? It's pretty cool to think about how these, like, fundamental principles of heat transfer can be used in something as complex as designing buildings.
It's true. Architects and engineers, they really use this knowledge of heat transfer to create buildings that are, well, more comfortable and more efficient and sustainable too.
So how do they do that? Like, what are some of the techniques or strategies?
Well, insulation is a big one. Remember how we talked about wool and how it traps air to prevent heat loss? Well, it's the same idea in buildings. Insulating materials, things like fiberglass or foam, even recycled denim sometimes, they're all used in the walls, roofs, and floors to slow down the heat flow between the inside and the outside.
So it's like wrapping the whole building in a big, comfy sweater.
Exactly. Good insulation keeps the building warm in the winter, cool in the summer. Less need for heating and AC, which saves energy and money in the long run.
What about windows? They seem like they'd be a major source of, like, heat loss in the winter or heat gain in the summer.
You're right, windows can be a big problem for heat transfer. That's why a lot of new buildings use double or even triple paned windows.
Oh, yeah, I've heard those.
Yeah, so they have this layer of air, or sometimes an inert gas like argon, sealed between the panes. That creates an insulating barrier to cut down on that heat flow.
So it's like a little air pocket in the window, acting as insulation.
Exactly. And there's also something called low emissivity coatings, or low E coatings, that they put on the glass.
Low E, okay.
They're super thin, these coatings, but they reflect infrared radiation. That helps keep heat inside during the winter and outside in the summer.
It's like sunscreen for your windows.
Yep, that's a good way to put it. And then there's more. The way the building is oriented and where they put the windows, that matters a lot too.
I guess that makes sense.
They'll position windows specifically to get the most solar gain in the winter. Let that sunlight passively heat the building. But then they'll try to minimize direct sunlight in the summer to prevent overheating.
So they're basically harnessing the power of the sun, using it to their advantage.
Right. By thinking carefully about all these things, insulation, windows, the building's direction, even shading, they can create buildings that are comfortable year-round and don't waste a lot of energy.
That's really impressive. Who knew there was so much science that goes into designing a building?
It's all about using those principles of heat transfer in creative ways to solve problems.
It really shows how much we can learn by taking a deep dive into the science behind everyday things. Today we went from the basics of temperature and how heat moves to how it impacts the clothes we wear and even how our homes are designed.
Yeah, we talked about how heat flows from hot to cold things through conduction, convection, and radiation, how those mechanisms can all work together, and how understanding them can help us make better choices, whether it's about what we wear or how we live.
We learned that light colors reflect radiation, dark colors absorb it, and that wool is a fantastic insulator.
And we learned how architects and engineers use these principles to create comfy and energy-efficient buildings.
Well, I hope everyone enjoyed this deep dive into the world of heat transfer. It's a fascinating science that's all around us. As you go about your day, think about those examples of conductions, convection, and radiation at play.
Yeah, think about that warm mug of coffee in your hands, the steam from a hot shower, or the sun on your face. It's a constant process, shaping the world around us.
Stay curious, everyone, and keep exploring. Thanks for joining us on this deep dive.